So previously we had 4 sessions for this B pillar as a BIW. So today we are going to see about the master section creation. This master section creation for the B pillar upper area. This is the example for the master section. This is the benchmarking data. Okay. So for this, what all the inputs we have been required, especially the B pillar lower hinge, B pillar upper hinge, the seat belt mountings, and the opening flange. This opening flange, usually it will be created by the door team. Okay. And for the door team, based on the styling data and which kind of door they are selecting, there are different kinds of door that I have been explained in the previous session. So this is the door glass channel area. Okay. This area we used to call it as a door sash. Based on the door sash, okay, this B pillar area, it will be classified into the 3 types. This glass area. First one, it's a full door frame. If, for example, most in the India, the previous generation vehicles, like previous Sandro, Swift, okay, and even Alto, those vehicles commonly they are using the full door frame type, even the Micra vehicle. Okay. The outer panel and the inner panel and the glass frame will be there. If you take the section. Okay. So this is the section for the door B pillar area. Okay. In this door, here you can visible the door outer panel and the door inner panel will be there here in the B pillar area. Okay. I will show some door data for your reference so that you may understand better. Okay. So in this, you can see the door, complete door outer panel, this one. The door outer panel itself contains the A pillar area, roof side area, and the B pillar area. And the inner panel also it will covers the A pillar area, roof side area, and the B pillar area. Between this, we used to have some glass run channel. This is the glass run channel. When you take a section, you can see the door outer panel, the door inner panel, and the glass run channel. Similar kind of door outer panel, door inner panel, and the glass frame. This is the part, the door glass run channel. In this area, the glass will be fixed. So this is the door glass channel section for your reference at the B pillar area. Number 2, steel sash type. In this, okay, the door outer panel, it will not cover the glass area. Only the door inner panels cover the sash area. So for this area, in order to cover the door glass area, they used to add the sash reinforcement. This is the separate part. in this area, they have been fixed this area. They have been fixed the glass run channel. And this area, they have been fixed the glass run channel. So when you take this section, this may look like this. This is not the door outer panel. This is the door sash. This is the full door frame B pillar section. This is the door glass section with the regular steel sash. This is the steel sash, not the door outer panel. This may look like this. Number 3. This is the second model, which will have a door panel. Outer panel will be only at the downside. In the upper side, we will have a steel sash only. Third type, it will be a aluminium sash type. In this aluminium sash type, door outer panel also, it will not cover the sash area. Inner panel also will not cover the sash area. Then what will be there in the sash area? We have some aluminium rails. These are aluminium parts. When you take a section, it will look like this. This is the aluminium channel. The next one, it's an aluminium channel section. This is the one. So before we making this body side outer master section, we must has to understand that which kind of door, okay, they are using. Based on that only, we will make the master section. This is the first step. You have to get the information from the door team. So, okay, how this sections influence, okay, our master section, the B pillar master sections. Okay, so once you get the styling data, the first step, for example, this area, okay, this is the styling data. Okay, you are taking the master section in this area. Usually, yes, this is the one you will receive. The styling data under the glass data under the B pillar, this door data. This much only you can get in the master section. Okay, I will show in the 2D sections. Okay, when you take a section, this is the door glass. And we can see should will come like this. When you take the master section at the styling data, it will look like this one only. When you take the styling data and you cut, it will look like this one only initially. Then if it is the full door type, okay, then this is the data will create by the door team. They will make the master sections. This is the hemming area for the door. Should look like this. It will be not like until this. Okay, and in this area, they will add the glass run channel. This is the inner panel, this is the outer panel, and this is the glass run channel. Same way they will do for the door data, rear door data also. Just a representation only I am making. And they will add the thickness to the door glass. Okay, so this is how they will complete the master section, and this area they will keep the door sealing data. This kind of door sealings will be there. This is a glass. This is the glass channel. This is the inner panel they used to create. And this is the door inner panel. Once they have been, then your work will be start from this point. Okay, so in this area, they will add some seals usually. This is the door seal. And based on this, they will develop the door sealing data. The door sealing data, it will come. This is the door sealing data, that is this one. This information. When you take the section, it will look like this. Okay, why they are making this door sealing data? Based on this door seals type. Okay. So this is the door seal. This is the body seal. This is the door seal, and this is the body seal. Okay, so when they complete this, next, okay, we have to make our master section. So until now, do you have any doubt regarding this? Please let me know. This is based on the full door type. If it is, for example, if it is the aluminum sash type, okay, it will not be like this. They will make the data sections like this way. This is the aluminum sections, they will make it. It is the aluminum sash type. This part will not come into the place. The door team will complete the, this is the styling data. They will make a section like this. It will come like this. Okay. So this is how, based on the styling, they will make the aluminum channel. In the aluminum channel, they will fix the door sealing just like this. Then they will make the door sealing data. This sealing data, based on the door seal types they have been select, they will give the gap between the door sealing, this data to this data. This aluminum channel first they will define. From this aluminum channel, usually 15 to 20 mm gap they used to keep between this aluminum to the door sealing data. So this is how they will make the aluminum door data for your reference. This is the input. This two surface and this two surface only you will get as a input. Then they will construct the door data based on the door type. This is the full door type. They will create it. This is the aluminum door type they create. Then if it is the which type that steel sash type. Okay. That also they will create the data like this one only. This is a door glass channel. Based on that, they will create the outer panel and the inner panel. Okay. First, they will give the this plastic cover data thickness they will add. This is the plastic part they will create first from the styling data. This is the plastic part. From that, they will give some offset value and they will create the door sealing data. This is the door sash data. This area, they used to keep the sealing. They will add this part. The same way, they will create the section. Okay, so this is the door sash. I will give some other color for your reference. This is the door sash. This is the door inner panel, and this is the conditions. So this is the input we get. From that, they will construct this one, the door tip. Okay, this concept, is it clear for you? From that only, we will start our master section.
Yes, sir.
Okay. So from that, we will start our master section by adding the small step for the sealing flange purpose. This to this, they used to keep 3 mm. Okay. Then from this surface, from the door inner panel surface, okay, we have to keep several distance based on the door sealing mounting. This is the door sealing. This is the water entry point from the outside of the door. Okay, if you do some cleaning from the outside, if you are trying to clean your vehicle and do some water shower, this is the way the water entry into the cabin area. So the air or water entry, okay, you can prevent by using the door seal. Next, from by the body seal. This is the body seal and this is the door seal. This is the body door seal. This is the body seal. This is the door seal and the body seal. Sometimes we used to keep here also the doors surface. Here, this is the door seal. So this one. So based on that, we have to keep some distance. This distance will be slightly vary based on the door seal type we have been select. Okay, for this door seal, there are many varieties are there. This is the door seals. You can see multiple varieties of these sections for this door seal type. So each OEM, they will go for variety of type. Here the type names they have given P30, P35, P40, P50. These are the types. Any of these types they will select based on the availability on the OEM. For some OEM, they constantly use the same type of seals. So based on this type, for example, what are the types we have been select? They have been kept the distance of 20 mm between the door inner to the body side outer. Then you have to keep this one, this to this distance. Okay, it is 20 mm based on the door seal type we have been select. Same condition here to here, we have to select 20 mm. Okay, then next from the door inner panel. So yeah, this is the door outer panel. This is the hemming area of the door outer panel. Okay, so this case, okay, based on the over slamming condition. Okay, when you suddenly close this door, okay, so this area we needs to kept minimum distance between the body side outer to the door inner panel. Here, this is the condition. This is the door inner panel. Okay, here you can see they have been kept 10 mm between the door panel to the body side outer. Okay, so this is the minimum distance you have been kept. The distance how they are kept due to the over slam conditions, how much it can travel and it can able to hit the body side outer area. Okay, so we have to keep some distance. For example, they kept worst condition. It may move 5 mm distance. That is the over slam condition. The body side outer, the door may travel. When you suddenly shut the door, it may travel 5 mm. Okay, so 5 mm is the worst condition for the door inner panel. From that condition, you have to keep 5 mm clearance. From the worst condition to the body side outer, we have to keep 5 mm. So from the original conditions, they kept minimum 10 mm. So this to this, they used to keep 10 mm. So this to this is the sealing data. From, sorry. From this sealing data, you have to keep 3 mm minimum. For the this seal mount and the steel stiffness we have to keep. Then from this point to this point, based on the condition, you can go for 20 mm based on the seals whichever we have been kept. and this distance from the body side outer to the door outer panel hemming area, we have to keep 10 mm by considering the clearance and the door over slamming condition. This is how you have to construct the body side outer panel on the B pillar area. This section, creation of this body side outer, is BIW structural team and department requirement. This will be done by B pillar designer. The remaining, whatever the this one, I will change the color for your reference. Okay. Creating this pink color only is BIW design team department requirement. Then this all the remaining area, it will be come from the door team as a input to you. So the same case will be applicable for each door type. For this door type also, the conditions will be same. So here to here, we have to maintain 3 mm for the door ceiling fitment. And this to this, the door inner panel to the body side outer distance, you have to keep 20. This 20 is not constant. It's just like a based on the seal type, whichever we have been selected. This to this, it will be 20 mm based on the seal type which we have been selected. But from this point, okay, so this distance, okay, from the hemming data, we used to keep 10 mm. But in this condition, this area, the door outer panel will not come. So this area, the body side outer will be slightly go inside compared to the previous condition. For the door full frame type, okay, the body side outer will come somewhat near to the door panel. But in this condition, this is the styling data, this one. So this line, so this is the styling. This green is the styling data. Okay, so from the styling data, this part, usually the plastic part will come in this cover up area. It will come around 4 mm. This plastic part. Then for the plastic part to the metal part, this area, they will add some glue material. This is the glue. Okay, some from this glue, they will apply 3 to 4 mm. Again, 4 plus 4, 8 mm. In this 8 mm, after 8 mm only, the door sash data and the door inner panel will be start. So from the door inner panel to the body side outer, we have to keep around so from this point, we have to keep 10 mm clearance. This door outer and the door inner panel, there will be a separate door team will be there. So when you work in the industry, there will be a door team as well as the structure design team. So you alone can't create the complete vehicle, right? Okay. Inside the
Okay, so
BIW design team itself, we have a separate team called the door design team and the BIW structure design team. Okay, inside your department, there are several teams will be there. One team is a door design team and another team is a structural part design team. We have to get the information from them. Then we have to start our master sections. So when they create the master sections, they will share with us. We will start to create our master section. During that time, they will start to create the door basic shape. So when we immediately get the master section of door, we have to start our BIW design. We have to start. So that's what I said. Apart from the pink data, all this information, it will be come from the body side, door team. Then we have to complete this section. Okay. In that case, here, it will be same conditions only. It should come closer this area. Okay, so from here, the 3 mm we have to maintain. From here, we need to maintain 3 mm. Then from this, the aluminum structure, we have to maintain 15 or 20 mm based on the seal type again. This is the final one. From here, based on the seal type, this distance we need to maintain. From here to here should be. And in this area also, they will keep the plastic pot, cover up pot usually. So that is the input for us. Okay, so this is the plastic pot. Like this, we will have a glue between the aluminum channel to the plastic pot. This is the styling data. This outer styling. From the outer styling, we will have a plastic pot. From the plastic pot, we will start to create the aluminum channel section. From that, we have to maintain from the aluminum channel to this one, we need to maintain minimum 10 mm. From this, maintain minimum 10 mm condition we need to maintain for the door slamming condition and the door to the body side outer clearance area. This is the very basic there is initial step to create the master section. So you may ask, you may ask that how once only the styling data only we have been received. From that, how to start the B pillar data. This is how. If you can't get to the door type and the door sections, you can't start the B pillar data creation. Okay, the B pillar area, it will not completely based on the styling data. For example, the roof data, okay, it is completely based on the styling data. the door data, the hood panel, the tailgate panel. All these panels completely rely on the styling directly. But A pillar data and B pillar data, these data are indirectly, okay, depends on the styling data. Okay, first we have to get the door information. From the door information, we can start our pillar designs. So in this now I will explain how to start the master section. Okay, as of now, I don't have the door data along with the seal and other information. So just I explain to you how to make the master section with the help of the door sealing data. In this section, we will create the this will fix it because this is input data for us. Okay, so this is the way we have to create the body side outer section usually. Okay, this one, as I mentioned, from here to here, we need to maintain 3 mm distance. From this, okay, we need to maintain from the door data to the body side outer data. We have to maintain about 15 to 20 mm. The same case here, the door out based on the door type and the uh, door styling data, we need to maintain several distance for the body. Usually this will be normal to the styling data usually. For example, data normal to the styling. Normal means normal to the styling data curve. If I select here, it will be normal to the styling curve. That is the first one. The point where I have to select is the middle point of the seat belt fixation. Okay, so I will rearrange the styling data under the then I will this is at the right place. The styling data, it's not in the right place actually. Okay, let me arrange that styling data according to this according to this one. I will arrange the styling data. This is the way we have to create the master section. I will explain how to create the B pillar outer and the B pillar inner section in the theoretical. In the tomorrow session, I will arrange the styling data and I will explain in the better way. So once you have been completed this master section for the B pillar upper area, okay, the next one, the B pillar outer section, you have to make it now. Okay, so usually it will become from this body side outer ceiling data, outer thickness. Usually body side outer thickness, it will be 0.65 or 0.7 mm. Assume it's a 0.7 mm. So this ceiling surface, we need to offset by 0.7 mm. Okay. Then this area, we need to keep 3 mm clearance. This area, body side outer to the B pillar outer, all around the area, we need to keep minimum 3 mm clearance. Here, you have to keep 3 mm, and only this area you need to make a touch condition. Other area you should not make the touch condition. The body side outer and the B pillar outer, it should be in the touch condition of the door opening flange alone, not on the other side walls. This is the mandatory conditions you have to follow. This is the design consideration. The design consideration, whether I have been taken in this session for you. So some of them who has been attended the BIW basics. So only the welding area, you should have a touching condition. Other area, you should maintain minimum 3 mm clearance. Okay. The reason for this 3 mm clearance also I have been explained. The touching surfaces alone, we can maintain the proper this one surface tolerance. For example, point plus or minus 0.1 mm. The remaining data, okay, we can maintain plus or minus 0.5. So this area, for example, if I open the B pillar data, okay, for this, okay, so this is the ceiling surface. This is the ceiling surface. Only this ceiling surface data alone, I can maintain the 0.1 mm deviation. Remaining data, we can go for the 0.5 mm surface deviation, that is stamping tolerance. So that this area, only these two surface, we have been go for the tight tolerance. Remaining area, we can go for the loose tolerance. In that way, we can save a huge amount in terms of tooling. That is one reason. Okay, other reason, during the vehicle running conditions, the panel slightly it will be vibrate. Okay, if we have been make a touching condition for the non-welding area, this will cause some annoying noise to the customer. Okay, so that for the better NVH, we can follow this condition. Minimum 3 mm clearance we have to maintain for the area. So this is how we have to create the B pillar outer section. This to this, it is 3 mm all around the area, apart from the opening flange. That is the opening flange is the welding area. So this is the mandatory. Okay, in the CAD condition, you have to offset by 3.7 mm. The reason 0.7 mm for the body side outer thickness and 3 mm clearance. So when you offset, just 3 mm offset is not enough. 3.7 mm you have to offset the opening flange. So the next one, the body side outer, body side inner section. This should be like this. This is the plain section I have been make. This is the body side inner section. Okay, so this body side inner section, this, okay, and this surfaces, how they have been defined. Okay, it is based on the boxy section requirement. This boxy section requirements. So this width you can't able to modify. It is depends on the door data. But this height from the body side B pillar outer to the this one. This is the top surface. Okay, this is the small emboss for the seat belt. So this area they have been added some small deeper sections. They have been added. So we can go for this kind of sections. This depth, okay, based on the seat belt mounting, and this one, okay, it is made based on the boxy sectional requirement. For the better doors, that means the B pillar stiffness during the running condition, the boxy section, this length and height, this boxy section inertia is pretty much important. This boxy section is pretty much important for the side crash for the crash purpose, as well as the vehicle torsional rigidity and the stiffness condition. This boxy section is pretty much important. Based on the sectional requirements, this depth will be decided. For some vehicle, it will be this depth from this point to this point. It will be very less. I will show some example. For some vehicle, it will be more. Here you can see this is the original condition without any parts. This is the proper boxy section. So this area, in order to get the proper body sections, here to here, they have been maintained about 20 mm. Okay, for this condition, this area, this is the body side, B pillar outer. This is the B pillar inner reinforcement, and this is the small. They have been maintained the smaller depth based on the rigidity, torsional rigidity and the side crash requirement. Here, okay, they have been maintained about 25 mm from the door ceiling flange to the door, if this is the one, in order to have a better boxy section. So this to this distance has been decided based on the section inertia requirement. If the section inertia it is very low, then push slightly 5 mm, 10 mm we can push for in order to get the better section inertia. So they will decide the B pillar inner this side surface based on the side section inertia. Usually it will not more, okay, it will be comes within 15 to 25 mm range. Not like a deeper section as a B pillar outer. That's how they will decide the B pillar inner section. When you make the B pillar inner section, from the door seal flange, you have to offset 0.7 for this panel. If it is 1.2 mm, assume that. So 0.7 plus 1.2 is 1.9. So this surface needs to be offset by 1.9 mm. This also need to be offset by 1.9 mm. Make the proper section. From that offset of 1.9, you have to make a inclined, it's a side inclined surface. The side wall surface, most of the side wall surface requirements, it is based on the stamping conditions only. So we can go for a better stamping condition more than 10 degree. This to this. Okay, for example, if it's 90 degree, 90 plus 10, more than that, okay, 100 degree, 105 degree, you can maintain this. And this surface, it is depends on the section inertia condition. Okay, this is this section and this section irrelevant to the door type because a body side outer won't change based on the door type. And B pillar outer and the B pillar inner all depends on the body side outer only. So from that you can directly construct. So there is a no difference for the door type. The B pillar outer and the B pillar inner section will not affect by the door styling or the door type. It is purely depends on the body. When you go for the master section of B pillar on the outer and the B pillar inner, it solely depend on the body. It will not affect by the doors. What are the doubts you have relevant to the BIW master section theoretical session? Data whichever we have been the input data we have been created from the styling, we will create the master section. So this is the three master sections we have been made for the body side outer and the B pillar outer. This is the body side outer data. And this is the B pillar outer data. Okay. The first key thing is from the body side outer data, how to make the data. This is the key thing. So first you have to make a basic surfaces from the master section. From the master section. This is the master section I have been made. This is the door ceiling data. This is the master section we have been created. This is the B pillar outer data. So from that we have been created the this is the top sections whichever we have been created. Then the bottom surface we have been created. Each surface we have been created. Once we created all these surfaces, the connection data creation. The data connections will be happen. This to this connection data. Then the joining operations. So this top surfaces, I have been joined with the help of trimming operation. This is one side of the data we have been created. This is another side of the data which we have been created. Then joining the all left side, right side data and the top side space. All this has been joined together. Then we have been splitted. Then we have been added the radius detail for each and every area. We need to add some radius information. Once the radius details has been added, the whole details. Whole. And other features, the small embosses for the striker. This area, the striker emboss will be added. This area, the check link embosses will be added. We can get the final data of the body side outer just along the B pillar area, not the complete body side outer. From that, we have been created the B pillar data. This is the B pillar data. From that, we have been created the radius details and other stuff. This is the B pillar data for your reference. So we will see one by one how to create the base surface from the master section. From that, how to join the data and how to add this features and other stuff. It will take next 3-4 sessions in order to complete this data. The next 2 weeks, we can able to complete this BP creation. Okay, guys, we will see in the tomorrow morning session. In the meantime, I will update the styling data relevant to the inputs.